Let's continue. Okay, yeah. Regarding this morning class, I have actually informed the class that because your class is 9 to 11, and then I have my next class 12 o'clock. So from Nilai, I cannot be rushing, 1 hour to get, for sure I will not. So that's why I moved today's morning class to the original time of Friday morning. Okay, actually, I wanted to make it earlier on Friday morning, 9 to 11. But all of a sudden, I will have online meeting at 9 to 10 tomorrow. So after the meeting, then I will do your class 10 to 12. Is it okay? Is it okay? It's just for this week, actually. Suppose should be on Thursday morning after, I mean, like next week. So is it okay? Everyone okay, huh? Okay. So tomorrow will be your practical, 2 hours practical. So tomorrow I want to go through your assignment title because we didn't check yet. Your assignment title, the modules, the functions according to the grouping I asked you to do. So we will go through that, and please do check on the template, the test plan template, which I have briefed you. So you can actually start with the first part, which is the context of the testing, where if you have finalized your system, okay, you can actually start to prepare the introduction part, the background of the system, and then the stakeholders and so on. Okay, but we will go through the system first, hopefully no much issue, so that you can start to work on your test plan. Okay, so that will be what I plan to do tomorrow. So just get yourself prepared about the system, the module, and also individual functionalities per member. Okay, so today we will proceed with chapter 4. So we already completed our chapter 3, which is the static testing. So chapter 4, we will start about dynamic testing. Okay, let me share my screen. Okay, can see my screen, chapter 4, which is the dynamic testing. Can see? Okay, so last chapter we already talked about static testing. It means the type of testing which we conduct before the development of the system. So it means we can test on the artifacts such as the requirement document, the design document, maybe the source code, the documentation, testing documentation, and then maybe the prototype, and so on. Okay, so whatever we do the test without execution of any source code. Okay, so now chapter 4 we will be discussing about dynamic testing. Okay, so we will be talking about dynamic testing, and then we will discuss again about the black box testing. Okay, if you see in our chapter 2, okay, chapter 2, after we discuss about the integration part, we have discussed about higher level testing. It means after we have integrated as a system, what are the type of system testing which we can conduct. So I think I have discussed around like 15 different test cases or 15 different type of system testing. So here we might be repeating some of the testing again because those system testing which we discussed in chapter 2 also categorized as a black box testing. So when we are discussing about black box testing, somehow we might be we might be repeating again. Okay. So after that, we will be discussing about various types of the black box testing and then the black box testing technique. Okay, please do not get confused between black box testing types and black box testing techniques. It's two different things. Okay, so black box testing type, it means more to the type of system testing which we will be conducting. For example, like functionality testing, performance testing, stress testing, all those kind of things. Okay, and when we said about technique, okay, the black box testing technique, it means for us to prepare our test cases, okay, in the future when we are going to prepare our test cases. So we need to choose this black box testing technique, the suitable technique for us to identify the the numbers of test cases and also the data of test cases. Remember, one of the principles say that exhaustive testing is impossible. It means we have combination of varieties of data or input which we can test, and we have no time to test everything. So this black box testing technique will be helping us to identify the right range of data, combination of data, and also to roughly give us the numbers of positive test case, the numbers of negative test case. So we need to use this technique so that we can avoid exhaustive testing in our testing activity later. Okay, so what is dynamic testing? So compared to static testing, which we have discussed in chapter 3, dynamic testing is where we are going to conduct the testing to test the system or any components by executing the source code. So it means we have completed the development, okay? Then we have the integrated system, or we have the integrated system with another system or with another environment and so on. So we will be conducting the system testing by executing the source code. So here we are not checking any documentation anymore. We have done that in the static test. So based on that, we already do the development. So now we have the completed source code, we have the system. So we will be testing the system by running the system, by executing the system. So normally, since we already have the system, so now we can test on the result or on the output which we can get from the system. So for us to produce the output, we need to provide the input so that we can get the output and we can observe the result if it's correct according to what we want the system to do. Okay, so for this we might need to create test cases. So it depends. If we are concentrating on the functional requirements or we are concentrating on the non-functional requirement, we need to prepare the test cases. Okay, so it depends. Okay, so when we say dynamic test, it can be black box testing and also it can be white box dynamic testing too. Okay. So when we said black box testing, so it means the testers will view the system as a black box because they don't care what is happening inside. So they don't care how the code has been written. They don't care about how the internal behavior of the source code. Okay, so all what they want to see is, am I getting the expected expected result or not. So it means this is this is actually based on the system specification, what the client requested. So the test case will be prepared according to that. So we want to test if the system followed according to the system specification or not. So when we concern on the system specification, we don't care. It means as a tester, we don't care how the system has been designed, how the code has been designed. So we don't care about all those things. So all what we want to see is we want to see how is the system functionalities and the features. So, according to the specification, we want to know where is the defect part. It means which part of the system does not behave according to the given specification. So, here we are not concentrating on the structure, we are not concentrating on the quality, we are not concentrating anything about the design, about the code, nothing. But what we are seeing is a black box. It means what I see is the UI of the system. And if I do this, if I provide this data, what the system give in a return. So that's what we are concentrating on the black box. So when we said black box, it's not only talking about the functionality, but we have other side also. It means how the system perform according to the specification given, how is the stress level, how is the response time. So all this is actually based on the specification given by the clients and also by the developers themselves. Okay, so these are the types of black box testing. Okay, if you see some of the testing I already discussed in chapter 2, because this testing also fall under the higher order testing. So when we said we integrated as a complete system, the system is done or system is going towards the completing areas. So we can also do the same testing there. So that's why it's kind of repeating on chapter 2 and chapter 4 again, because on there it is more as a higher order testing. It means as a system. Okay, and here is it's categorized as a black box testing. So whatever testing which we already discussed in chapter 2, I will just go briefly. Yeah? Okay, so we have functional testing, smoke, sanity, regulation, load, stress, exploratory, performance, usability, recovery, acceptance, and this two is actually under the acceptance as what I have discussed in chapter 2 and some others. Okay, so let's see one by one. So when we said functional testing, I believe by now you already know what it's mean by functional testing, where we are actually testing if the system is functioning against to the functional requirement or given specification. Okay, so normally when we said we want to see this function if it's working or not, so we need to provide the input, we follow the given test steps or action, and then we want to see how is the output, are we getting the correct output according to the specification given or not. Okay, so when we said we want to do functional testing, so it is involved with these steps. Okay, so first is we need to identify the function. It means what function from this particular software or system which we want to test. Okay, then according to that function we need to create the input data. So it means according to the function specification, we need to know what data we want to use. So this can be fulfilling the success of the functionality or the error handling of the functionality. Then we will determine the output. So it means for this given input data, what should be the output? So we determine earlier. So that is what we call as a expected output. Okay, then we will execute the test case. So now after we identify the function, we have created the input data, we have determined the expected output. Now we will execute the test case. So all this information will be prepared on the test case. So we will execute the test case, then we will actually get the actual output. So when we have expected output and we get the actual output, we will do the comparison if both of these output are tally or not. Okay, so if both they are tally, it means our expected output is say A. Okay, our actual output also say A. So it means they are tally. So it means the test case is passed. So the function is successfully doing what it's supposed to do. So let's assume our expected output say A and our actual output say A minus. So it means they are not tally. Then it will be failed test case. So the failed test case, it means due to the defect. So we have to fix the defect. So that is how we conduct the functional testing. Okay. Then the next one is smoke test. Okay. So smoke test is a normally the system has been completed and the system is going to be moved to the next testing stage, to the next stage, which is the testing stage. So as a development team, they need to conduct this smoke test, which is to confirm that the system is fine. Okay, so another name for smoke testing is build verification testing. So this will be conducted by the development team to confirm that the system is completed, the system is having all the functionalities, all the main function, all the sub functions, and the system is stable enough to start to do testing. Because we don't want where we have received the system, we do the testing and the system actually not stable to proceed with the testing. It means the system keep on crash or the system keep on hang, the system did not functioning or the system did not have some some, how to say, like the features of uh, what it supposed to do. So to confirm that, the development team will do the smoke test. The system must pass this smoke test before it will move to the testing stage. So normally, one of the test entry criteria, okay, let's assume we want to conduct a testing on a newly developed system. Okay, this is nothing to do with your assignment, a newly developed system. So in that case, the development team must conduct the build verification testing or the smoke testing to confirm to the testing team that the system is done, the system is ready for testing. So that is what we call smoke test. So this has nothing to do with the development stage, but actually after the development stage, before the development team pass the system to the testing team. Okay. Then regression test, I already discussed in chapter 2, where every time when there is a modification happen on the source code, we will conduct the regression test to confirm that the new changes happen did not create a new problem. It means there is no new defects. The system is performing well. The system is doing what it's supposed should do, and it is actually producing what we expect to see. Okay. So regression testing actually can be conducted at different level. Okay, so like normally during the development also, whenever there is changes happen, because whenever there is any debugging happen or there is changes of requirement happen, of course we will change the source code. So whenever there is changes on the source code happen, we conduct the regression test. So even after the system has been completed, when we are doing any debugging or any changes, regression tests can be conducted again and again. So this can be covering the functional side and also the non-functional side changes. Okay, then we have sanity testing. So sanity testing is actually known as a subset of regression test. So when we say the regression test, it's actually being conducted on the entire system. Okay, every time, every single changes, the entire system will be tested again. Okay, but when it comes to sanity testing, we do the repetition of the testing where the changes happen. So it means we narrow down the regression testing and focus on the functionality or the area where the changes happen. So it means, let's assume the changes happen only in one module. So something to do with the functions closely at the module A. So the module B, module C, D, and so on will not be tested. So our focus here is only at that particular changes area. So it means the repetition testing here, the regression testing here will be much more narrow and deep on the changes part only. So it means it will be focusing more where the changes happen. And this is suitable when there is minor changes, because sometimes when a change has been made, okay, and we only tested the area where the changes happen, but we did not test the other functionality which is surrounded, this can actually leave a hidden defect. So that's why regression testing will be better, because we test the whole system again and again every time there is changes happen. But let's assume if the changes is very minor changes, maybe it's not really impact on many functions, or maybe it did not even impact the functions, maybe it's just like simple changes on the UI or anything, but it is involved with the changes of the source code. So we can concentrate on running sanity testing instead of regression testing. So when the changes is small and we know that it is not affecting the other areas and it is not going to have a high risk, so we can concentrate on sanity testing instead of regression testing, because it's not easier to conduct regression testing again and again, and especially if the company did not utilize automation testing, then it's going to be a disaster. So that's why automation testing tool is a very important, especially when the company is welcoming changes. Requirement can be changed last minute, all this happen. So every time when client requests for changes, actually there will be changes on the source code. So these changes must not give problem to the system. So we need to conduct frequent regression testing. So if we have an automation testing tool, it will be much easier to do. Okay, so that is regression testing and sanity testing. The next one is load testing. So actually this load testing, stress testing, not this one, after the stress testing, performance testing, and then we have another one more. I'm not sure if it's there. Okay, so this load testing, stress testing, volume testing, which I have discussed in chapter 2, and also performance testing. This is a very close to each other. Okay. Actually, we want to see how the system perform. Okay, but each of these testing still has the own aim where they are checking something. Of course, it is somehow affecting the performance. We want to see the performance, but we are actually trying to see from different angle how the system perform. So if we say load test, it means we want to see how the system able to behave under a specific expected load. So it means we are giving the expected load and we want to see how the system perform. Okay. So normally this load, okay, can be happening at the normal time period and also at the peak. So for example, like today, this is end of month. Okay, so if you walk into ATM, right, you will see a lot of long queues happen. Why? If you go to any bank, you will see long queue at ATM. Why? Compared to other normal days, why today or why tomorrow will be a long queue? Are you guys no more walking to ATM? Why normally end of the month? Today is the last day of November, right? Yes, the salary out time. So if you see, normally end of the month or the first week of the month, this is a peak time due to salary payment. So the example which I gave just now is ATM. It's a physical thing. So it means like, okay, you go and then you see a long queue. This can happen in a system too, because when it comes to online banking, okay, especially this public bank, okay, I think now it's getting better, but this PBE was having a lot of issues end of the month and the first day of the month. This is because the system cannot handle the certain load. So normally we will determine how the system behave or perform under the normal time. It means with the normal load and also during the peak time with additional load. Okay. So we want to see what is the maximum operating capacity which the system can handle. Okay. So if the more the load is being increased, what happened? Okay, so we want to see if there is any bottlenecks happen. Okay, so normally load can be different types of load. So it means maybe the numbers of devices, the numbers of transactions, the numbers of requests coming in, or the network, the usage of bandwidth. So all this can be affected, affecting the performance of the system. So all this is under the load test. So we want to see how the system behaves. Okay. And when we said stress testing, okay, it's still about the system behavior, the system performance. Okay. But what we are trying to see is when the capacity is gone beyond the normal capacity. It means I stress the system. Okay, so when I give something beyond the normal capacity, then we want to see where is the stability level and where is the breaking point of the system. Because the more we are stressing the system, okay, the more we give, the heavy load we give, it can change the behavior of the system. And some system can handle those stress and some system cannot handle, then it will be a crash happen. So our aim to conduct here is we want to see the system should able to perform correctly without any issue, without any crash. So our aim conducting the stress testing is we want to see the stability of the system. Okay, so load just now is by giving the expected load. Okay, on a